Hello, everybody. We are Group 4 from the Probability and Stochastic Process class. My name is Nadya Myesha.
My name is Naufal Aulia Amanullah.
My name is Renaldi Yoriz.
My name is Robbiarsya, Syaiful Akmal.
My name is Sanditya, Larope, Sutanto.
And we are here to explain about the maximum a posteriori or map of the probability and stochastic process.
Okay, today we want to explain about maximum a posteriori or MAP estimation. As we know, the posterior distribution where probability density function or PDF, which is the function x given y, or the probability mass function or PMF, which is the probability of x given y, contains all the knowledge about the unknown quantity of x. Therefore, we can use the posterior distribution to find the point or interval that estimate of x. Then, one way to obtain this point or interval that estimates of x is by choosing the value of x that maximize the posterior probability density function PDF or the probability mass function PMF. This method is called as a maximum a posteriori or MAP estimation. Okay, next, here we can see these two graphics. The maximum a posteriori estimate of x given y. The MAP estimate of x is usually written by x estimator MAP, as you can see here and here. The right one, this is the PDF or the probability density function, and this the left one is the probability mass function graphic.
Okay, after Naufal already explained to you the map estimation in general, now I will explain to you the map estimation more detail. The map estimates of the random variable x, given that we have observed y is equal to the lowercase y, is given by the value of x lowercase that maximize. So, the function of x given y, if x is a continuous random variable, and the probability of x given y if x is a discrete random variable. So, the map estimate is shown by the x estimator map.
So now I will explain about how to find the map estimate. In order to find the map estimate, we will need to find the value of x that maximizes the function x given y of x given y equals to function y given x of y given x times function x of x divided by function y of y. As you can see, the function y of y does not depend on the value of x, as it does not accept any x input. So, equivalently, we can find the value of x that maximizes the function y given x of y given x times function x of x. This, by finding the value of x that maximizes this function, we can significantly simplify the process of finding the map estimate, because finding the function y of y is usually done by using the law of total probability, which involves integration and summation. So we can avoid this complex process by finding the value of x that maximizes this function instead of this one.
Okay, after that, the MAP estimate of x given y equals to y. To find the MAP estimate of x given that we have observed y equals y, we find the value of x that maximizes this equation, which is x estimator MAP y equals to argument max over x, function y given x, function x. It's also equal to the equation argument max over x, function x and y. The map estimation procedure requires the known PDF or probability density function, function x. If either x or y is discrete, we replace its PDF or probability density function in the above expression by the corresponding PMF or probability mesh function. The MAP procedure needs the a priori probability model for random variable x. This is analogous to the requirement of the map hypothesis test, knowing the a priori probabilities. In the absence of this priori information, instead, implement a maximum likelihood or ML estimator, which will be explained in another topic.
I have an example problem. Now let x be a continuous random variable with the following PDF of function x equaling to 2x and 0, with the condition of 0 is less than equal to x and x being less than equal to 1 or otherwise. And also, suppose that y given x equals x, or is geometric. Now, we must find the map estimate of x given y equals 3. From there, we get this formula, or this equation. Because from what we know is that y given x equals x. So we get the probability of y given x equals to yx, which equals to x, open bracket, 1 minus x to the power of y minus 1, and this is for y equals to 1, 2, and so on. And we know that y equals to 3, so then we substitute the y with 3, and we get probability of y x equals 3x, which equals to x 1 minus x to the power of 3 minus 1, which is to the power of 2. Now, after that, we need to find this. And the value of this that maximizes can be written as the probability of y given x equals, probability of y given x, open bracket, y x, and function of x equals to x 1 minus x squared times 2x, which can be simplified into 2x squared times 1 minus x to the power of 2. Next, we can find the maximizing value through differentiation. From that, we obtain the equation of d over dx x squared 1 minus x squared equals to 2x 1 minus x squared minus 2, open bracket, 1 minus x times x squared equals to 0. And when we differentiate everything and jot it all down, we can solve for x and check the maximizing criteria. and then we can obtain the map estimate of 1/2.